to be here with you today and talk about some probability, some counting, and some combinations. And so we're going to do that in section 10.2 here. We're going to break it into two parts. In the first part, we're going to talk about combinations, when and why we use them. So let's get started. We're going to jump right in. First problem is very similar to a problem that we've seen before. Let's say that there's 9 teachers here at Everest, and they decide to have a race. And we want to figure out how many different ways the top 3 can advance. Okay? So it is not the final race. These top 3 are going to advance to the final race. So what's important about this, and what's different about this, is that we don't care. There's no difference between first, second, and third place. All of them are going to advance. So whether you finish first or third, it doesn't matter because you're going to the final. So that's different than the last problem, because in the last problem, first, second, and third were all different places. But in this one, the order that they finished doesn't matter as long as they finish in the top 3. So here's how we deal with the problem like that. There are 9 ways we can pick a winner. Once we pick a winner, there are 8 ways to pick a second place finisher, and 7 ways to pick a third place finisher. So this so far looks exactly like we've done before, but it's too big. And here's why it's too big. Let's say that the 3 finishers were A, B, and C, and they finished in that order. So those 3 move on to the finals. Let's say if we looked at it differently, we had the racers finish A, C, and B. Well, even though this is a different order of finish, the same 3 people move on to the finals. And so we can't count that as 2 separate things. And in fact, if we listed all the ways that they could finish, these are all different orders, but in all of these different things, you have the same 3 people going on to the finals. So 9 times 8 times 7 counts all 6 of these as different things. We want to count it as just one result. That's it. And so what we do to fix that is we take this 9 times 8 times 7 and we divide it by however many repeats that we have here to give us the same result. So to figure out how many different ways these can be repeated, we just take however many there are 3, and we write down however many ways those 3 can be rearranged. And it can be rearranged in 3 times 2 times 1 ways. Okay, so another way, or I guess that's it. All right, what you end up getting here is you end up getting, let's see, 3 times 4 is 12 times 7 is 84. So there are 84 ways that these teachers can finish the race. Okay, and the top 3 advance. So this is what we call a combination. I'm going to show you what this combination looks like here, down as an equation. Now, unfortunately, this didn't copy very well. I apologize for that. So I'm going to rewrite it for you. This is called the choose function, or the combination function. It's n factorial divided by r factorial times n minus r factorial. You're welcome. Bye. Okay. So how do we use this? Well, if we get 9 people in a race and we want to finish, see how many ways they can finish in the top 3, we can do this 9 choose 3 function. That gives us 9 factorial over 3 factorial times 9 minus 3 factorial. And if we work that out, that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of that divided by 3 times 2 times 1. That's 3 factorial. And this will be 6 factorial, so that's 6 times 5 times 4 times 3 times 2 times 1. And as you can see, the 6, 5, 4, 3, 2, and 1 will all divide to 1. And you end up with 9 times 8 times 7 divided by 3 times 2 times 1. Which is what we thought it was in the first place. And so there is a way to type this in on your calculator. And I will show you that right now. A little background here for you so you can see it a little bit better. didn't work. There we go. So you go to the math button. Well, if you have the old version of the calculator like me, go to the math button, arrow over to probability, and you can see that the third option there is NCR. That's our choose function. And so the way that we use our choose function is we go way before the choose function and we type in how many do we have in the race. That's 9. And then after the choose function, we're talking about how many we want to order. It's 3 of them. And if you type it in, it'll tell you 84. So that's how you can type it into our calculator if you'd like. Or you can just do it by hand. That's always fun to do. All right. So that takes us to the next example. All right. Now, what's important about these combinations is that order is not important. Okay, that's the first thing that we have in there. Order is not important. All right. So we have to be able to decide when order is and when it is not important. So let's take a look at this example down here. You have 10 books. 5 are fiction and 5 are non-fiction. The question is, how many different ways can you read 4 books if order is not important? Okay, well, order is not important, meaning we could read these 4 books in any order. We're just trying to figure out how many ways we could read 4 of those 10 books. Okay. So reading A, B, C, D is the same as reading B, C, D, A. All right, we don't want to count that as multiple things. And so the way that we figure that out is we say, how many, well, this is 10. After we choose the first book, there are only 9. Then there are only 8. And then there are only 7. So that's the number of ways we can choose 4 books in a particular order. But since order is not important, we have to divide out all the repeat reads, meaning we don't want to count A, B, C, and D as different from A, B, C, or A, B, D, and C. So the way that we do that is we have to divide by how many different ways we could rearrange those 4 books that we picked. And that's 4 times 3 times 2 times 1. This eliminates all the repeat reads where we just read the same 4 books in a different order. Okay, another way that you could type in is if you wanted to use your calculator, you could just do 10C4 and you could type that in. All right, but when you multiply this out, I think you get 210. So there are 210 ways that you could read 4 of those 10 books. All right, looking at the next question regarding the same example, it's asking how many ways are all 4 fiction or all 4 non-fiction. So these are 2 separate problems, so we're going to solve them separately. Let's solve the all 4 fiction one first. Well, there are 5 fiction books, and we're going to read 4 of them. So we can pick them out in 5, 4, 3, 2 ways. 5, 4, 3, 2, sorry. Well, again, we don't want the repeats, so we divide it by 4, 3, 2, 1. Okay. Or in other words, this is just 5C4. There are that many ways that we can read all 4 fiction books, which turns out there's ways we can do that. Now, let's talk about how many ways we could read all 4 non-fiction books. Well, it's very similar, actually. Okay, 5 ways to choose the first book, 4 to choose the second, 3 to choose the third, and 2 to choose the fourth. We divide that by 4, 3, 2, 1. Because the order that we read them is not important. And we get 5 here as well. So when it's asking us a question, how many ways total are there to read all 4 fiction or all 4 non-fiction? It's asking us one or the other. It's not saying how many ways can you read 4 fiction and then 4 non-fiction. It's saying how many ways can you do this or that. So whenever we see that word or like that, all we have to do is we just have to take our 2 results that we got. 5 ways to read fiction and 5 ways to read non-fiction. And we are going to add them to get a total of 10 ways to do this. So some of these kind of get a little bit confusing because we're not sure whether we're going to add our results, we're going to multiply our results. It's a little bit confusing. So there's a little trick that we can use. It doesn't always work, but it works almost all the time. And it's listening to the wording of the problem. There are two keywords. One of the keywords is or, and the other keyword is and. If you need to find a number of ways to do event A or event B, then you just add the total number of ways you can do each. Sort of like we just did in this previous problem up here. But if you look for the number of ways to do event A and to do event B, then we use the fundamental counting principle and we're going to multiply those two results. So I'll show you an example, one nice example here of what I mean by that. Before we move on. All right, so here's our last examples here. The student council consists of 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. How many different committees of exactly 2 seniors and 2 sophomores can be chosen? So I want to draw your attention right away to that word and. That usually means we're going to be multiplying something. But let's take a look. Let's first look at how many different ways we can get exactly 2 seniors in our committee. Now, the order that we choose these seniors doesn't matter because they're both going to be part of the same committee. So there are 6 seniors and we want to choose 2 of them. So we can either do 6 times 5 divided by 2 times 1. Or if you wanted to write it using the choose function, that's 6C2. Now let's look at how many different ways we can choose sophomores. We want to choose 2 sophomores as well. With sophomores, there's only 4 of them. So 4 times 3 over 2 times 1. Again, that is 4C2 if you prefer using that notation. All right, and then what do we do with those 2 numbers? Well, since this is just one committee, we're choosing this group, and then we follow up by choosing this group. All right, we multiply these 2 values together. And when we multiply those 2 values together, we get, I think, 90. Okay, now I like to think of it this way. If we did 6C2, 6 times 5 over 2 times 1, there are 15 ways to choose the seniors. And for each of those 15 ways, there's going to be 6 different ways to choose the sophomores. So for each of the group of 2 seniors, there are 6 different ways that we could choose 2 sophomores. And so what we end up doing is multiply them together to get the total number of ways to choose this committee of 4 people. Okay. If you look at the next problem has another keyword, but it's or. How many different committees of exactly 4 seniors or 4 juniors can be chosen? So the difference here is we're doing one thing or we're doing the other thing. We're not going to do both. With the previous, we were doing both. We were choosing 2 seniors and 2 sophomores. So if we want to do this one, we're going to solve 2 separate problems. 4 seniors is going to be 6C2 again. We already did that. 4 juniors, there are 5 juniors. So we're going to do, sorry, mistake. Hopefully you guys caught that. 64. So we're choosing 4 seniors. And then juniors would be 5 C4. There are 5 juniors, we're choosing 4 of them. And because we're doing one or the other, we add those total results together. And so I believe we get 64 is 15. 5C4 is 5. So there are a total of 20 ways to do that. So finally, that takes us to one last type of problem. It's the at least or at most problems. At least means, for read the problem, tossing 10 coins, how many different ways we have at least 4 heads? At least means 4 or more. Notice that keyword 4. So when we a bunch of our results together. All right. So to get 4 heads out of 10 flips, there are 10 C4 ways to do that. Okay. You can get it. Basically, you have 4 spots, and you're only choosing, or 10 spots, you're only choosing 4 of them for heads. Okay, for 5 heads, because remember, we're doing 10 or more, it would be 10 C5. And, we keep going. There's 10 C6, 10 C7, 10 C8, 10 C9, 10 C10. We have to find all of these and add them all together. Okay, and unfortunately, that's the easiest way to do it. So I'm going to pause here right now so I can find the answer for you. And so the result is 848. And there are that many ways that we could toss at least 4 heads. Okay, so very similarly, if you're tossing 5 coins, how many different ways we have at most 3 tails? At most means 3 or less. You see the word or again. That means 3 or 2 or 1 or 0, which we often forget about. So we want 5C3, 5C2, 5C1, and 5C0 because we want 3 or less. So this is the number of ways to get 3 heads, 3 tails, 2 tails, 1 tails, or 0 tails. Okay, so if you add those up, you get 6. 26 ways. Okay, so that's going to do it for the end of this video. Check back for another video dealing with Pascal's triangle and binomial theorem. Okay, the main thing that I want you to take away from this one is that we can use combinations for a number of different situations, but most importantly, the order does not matter in those situations. Have a wonderful, fantastic, and beautiful day, and I will talk to you later.